In this video, we're going to cover conditional execution of statements in C++. So normally, up until now, when we've written a program, it's going to be a sequential flow, right? It starts at the first line, goes to the second line, third line, till we're done, okay? So to add more flexibility to our programs, we're going to want to be able to have some statements that don't always get executed. So we have more than one path through the code, okay? So in this first example, it would be a one-way selection. So, we're coming down through our code to the circle, to the circle here, and we usually represent these decision marks in a flowchart with a diamond. So in this diamond, it's going to be what we call a logical or a Boolean expression. It's going to be something that evaluates to true or false. Okay, so it's going to be using the relational operators, which are equals, not equal, less than or equal to, greater than or equal to. It's going to be one of those in there. And that statement will evaluate to true or false. If it's true, we do some statements. If it's false, we don't. Okay, just a one way around it. Okay. So an example here in some code, we have if score is greater than or equal to 60. Notice that the Boolean expression is in parentheses. Okay. And the book doesn't have the curly brackets here if there's only one line below it. Okay. In this case, it wouldn't need it. But I'm a firm believer that it makes more sense and it makes the code more readable to go ahead and include the curly brackets. So this is what I'm going to recommend that you do. Okay, so this one, we've got our if the score is greater than or equal to 60, then this grade equals P will be executed. There should be a semicolon there that I've forgotten. If not, it will not be executed. And it will go on as always. So the first line after the curly brace, doesn't matter whether this is true or not, is going to execute. Okay. So that's different from the two-way selector. Stats would be all on the same page. Okay. So the two-way selector is when we have more than one way to go through the structure. Okay. So in this case, we come into our decision statement and it's still true or false. Okay. But if it's true, we're going to do one set of statements. If it's false, we're going to do a second set of statements. Okay. So we then come back to the circle and execute in unison from there on. Okay. So that allows for a little more nuanced things to happen. And we do the if and the else. Okay. This is very much like Python. Okay. But we do have to have the expression inside of parentheses. Okay. So if, quote, hours is greater than 40. So in most systems, that means they've worked overtime. Okay. Then all of the statements within the curly braces are going to execute. Again, if there's only one statement there, these curly braces are optional, but I like them to be there. Okay. So then we're just going to take our hourly wages and take part of it. The part that's over 40, it gets 1.5 times the rate. Okay. But now we have an else. Okay. So the else is outside of the curly brace for the if. Okay. The else has its own curly braces. Okay. For its statements, and then we do differently. So if this condition's true, this line or lines execute. If this is false, this line executes. Okay. In no case do both lines execute. Okay. So that's kind of how that works. So let's now take a look over at the code. So I'm going to switch over to Warp, one of those W programs. So I'm on the server now. And if you see, I've logged in as the ABC123 test student. Okay. If you do a PWD, you see that I'm in my home directory and in my CSC 1180 directory, which is where I want to be. Okay. So I've gone ahead and created just the basics of a file here. So I've got my include IO stream, my using namespace standard, and I've got my int main. Okay. I do need my return 0 as well. Okay. So to look at how some of these things work, okay, let's look at the different Boolean expressions we can have. Okay. So remember when we're doing equality, just like in Python, equality is two equal signs. Okay. One equal sign is assignment. If I say X is equal to 5, make this screen a little smaller so it'll appear bigger to you. I think is how that works. Okay. In this case, what I'm doing is I'm assigning 5 to X. And we're assuming I would have had to, and I didn't, I would have to initialize first. Okay. Whereas if we were to say X equals 5, we're now asking a question. Does X equal 5? Okay, so that's the basic idea of the difference between those. Okay, so the equals looks like that. So that's equality. Not equal, it's an exclamation point equal. That's not equal. Greater than, pretty straightforward. There's no greater than or equal symbol on the keyboard, but we can do them sequentially, greater than or equal to. We do a less than, we do a less than, or equal to. Okay, so all of those are fair game. All of those will evaluate to a true or false. That's what our Boolean expressions are going to do. Okay, so the Boolean expression, these typically take two sides. Like you say something equals to something else, something greater than something else, or whatever. Okay, so that's the basic way things work here. So we can do something pretty basic here. Let's say we have an int age. Okay, and the age is equal to 15. Okay, we can say something like if age is, put Python again, if age is greater than or equal to 21, we can do something like cout legal age. We can use a similar example. Okay, and I can just end it there for the one way. Okay, so if I run this, it shouldn't do anything, right? If I compile it. Again, I'm not using the dash O, and I should be, but I'm not. So it didn't do anything, right? Did it really work? You never can tell. And the last chapter talked about using couts just to make sure. But all I would do here, I think it makes some sense. You want to know the result of this, right? So I'm going to do an else. And the else, I'm going to say cout underage, or whatever you want to put it. Okay, so run that. Now it says underage or underaged, maybe, whatever, doesn't matter. Okay, so basically that's the way it works. So again, what the book does, which I don't like, is that. That works is fine if there's only one line, but if I were to add a different line, like cout, drink up, let's say. See, it's already giving me trouble. The spacing's wrong because it doesn't work that way. Okay, so in this case, I would have to put in the brackets. That should fix things. See that it does. Okay, and I just like the brackets in there all the time. Okay, if you've ever had Java or JavaScript, somewhat, they tend to do this, which works, but I don't like that either. Okay, I prefer it this way. I think it's cleaner. Okay. So that's the basic way we're going to do these, right? So there's not much else to them as far as the basic structure goes. So we'll definitely be doing some examples in class where we go through on how to work these programs. Okay. So there are a couple of things that we can do here. And the first one is kind of, I'm not real fond of it, but you can assign an integer to the result of one of these Boolean expressions. Okay, so I could say something like int x, doesn't matter. I can say x is equal to age greater than or equal to 21. Okay, then I can cout x in line. So I'm sending to an integer the value of a Boolean, and it gives me a 0. Okay, so basically, if it's true, it would save it as an integer 1. If it's false, it saves it as an integer 0. And I just don't really see the need for that. If you see that in code, that's what it's doing, but it's not something I recommend. Okay. The other thing that we can do is that we can have Boolean variables. Okay, so a Boolean variable is one that stores either true or false. Okay, so if I type in BOOL, it's named after George Boole, who's an English mathematician who came up with a lot of the fundamental logical algebra stuff that we do. Okay, so if I say Boolean legal, okay, now that's a variable, and then I can here say if, okay, so actually I can just say, don't need that. I can just say, let me get back right here. I can say legal is equal to that. Okay. And that should give us, then I'll see out legal. See, I didn't put my parentheses or my semicolon. So it's giving me a hard time with the spacing. It's a good clue that there's trouble. And should fix it back. Okay. So if we do this, I haven't made a typo, made one yet. There's always plenty of time. It's going to come back as a 0. Okay. But it is going to be stored as that Boolean. Okay. What we'll more likely want to do, because that looks a little weird. We could do here, I think that was false, a 1 to be true. Okay. I think it's cleaner to go ahead and put our if statement back in. Okay. And then we can set this the more appropriate ways to true and false. So I can say if age is greater than 21, I can set legal is equal to true, all lowercase. Okay, close parentheses, do an else, open parentheses, legal is equal to false. Okay, and note that when we run it now, it still prints out a 0 because it doesn't print out the true or false, but I can directly set those values and it's fine either way. Okay. Note that once you have those Booleans, so since our if statements need a Boolean expression, I can now say if legal. Okay, I don't need to say if legal equals true because legal is either true or false. Okay, so then I can do my cout. Legal age else cout underage. Okay. That now, see, it's underage. Okay. Now it's not wrong. So if you say if legal age is equal to true, that should work exactly the same way. So it's not wrong. I would say it's less right. Okay, it's redundant. Okay. So you don't need that in an if. Okay. And that's really it. Okay, for the first part of this at least. So when we're dealing with, I guess there's one other thing. If we're dealing with characters, chars, we haven't dealt with chars much yet, but we've talked about chars. So char is a data type, just like ints and floats and doubles, and now we have bools. A char is just a single character. Okay, so if you go and try to do the relational operators on chars, you get kind of some weird results because chars are based on this thing called the ASCII table. It's an ASCII value, so every letter has a number associated with it, so it can be stored in the computer basically. Okay, so if you're dealing with uppercase letters, then an A is less than a B, which you would expect. Okay, but the trouble is that uppercase letters come first in ASCII because they were around first. So an uppercase A is less than a lowercase a, which seems strange. Okay. So if you're dealing with characters, which we're not dealing with characters much yet, but if you're dealing with those, you can say, are they equal? Are they greater? And it will keep them in lexicographic order or ABC order as long as they're of the same case. Okay, uppercase or lowercase. Okay. If you try to compare dissimilar data types, you sometimes get weird results. So you have to be careful with that. Okay. But that's the basic idea. It's pretty straightforward. Okay. So in the second half, the second part of this video, we'll talk more about some other things we can do with our if else's. But this gets us going, right? And this is a good thing. I mean, I think we struggled a little bit in not having conditionals, not having loops compared to Python. So those are both coming. Okay. So questions, let me know.